Okay, so let's start our lecture today. So let's start by calculating the quotient between this omega k prime z and sigma k prime z and sigma z. Uh, so okay, so okay, so I feel like what we can do is that yeah, I feel like we can do like term by term, right? So because yeah. Yeah, somebody asked me to wipe the board, but I think this place cannot be cleaned. Yeah, so maybe I'll try to find a way to clean it in a deeper, yeah. Okay, so so for this sigma k prime z, so so if we, so this sigma k z, okay, sorry, sigma z, okay. Yeah, so sigma z is basically equal to sigma kz for this z in k, right? Okay, so what we do is that we just divide by sigma z. Wait, where is okay? So yeah, so let's just say that, okay, sigma k prime z over sigma kz, okay, which is equal to okay, so let's first focus on the first term, right? So for the first term, so for the first term, so this whole thing, right? So this whole thing would cancel out with the product from j equal to 2, right? So therefore, what's left on the denominator is just z times the first product, 1 minus z over omega j. Oh, sorry, I think it should be omega 1. Okay, so 1 z times 1 minus z over omega 1 times z times z e to the z over omega 1 plus 1 half z over omega 1 squared. Okay, so this is what happened on the denominator. And on the numerator, wait, what happened? What happened when this z is equal to 0? Oh, this is because this function is not defined as 0. Okay, so we don't need to care about this z equal to 0. So we only need to okay. So what happened? Yeah, and also the lattice point as well. Yeah. Okay. So yeah. So yeah, strictly speaking, I think this should be sigma z now, right? Because I want this yeah, so I wanted to say yeah, I want to say the sigma k of z naught. Okay. Wait, so this is not true. Oh, okay, this is true. Okay, this is true. Okay. So let's continue. Okay, so won't bother. Because this z basically is defined for all z's in k. This function is being defined for all z in k. Okay, so we are fine with that. So okay. So for the derivative, right? So for the derivative, so this whole thing is being cancelled out, okay, by the division, by the division here. So then what's left is just the first term, right? Okay, so for the first term, I think for the first term we can pull out these exponentials, right? So these exponentials can be pulled out. Yeah, so let me just write it here, and then these exponentials will be cancelled out with this term. Okay, so shoot. I think I was wrong here, right? I think by using the product rule, it should be just 1 over omega 1, right? Let me check. So first I take the derivative of this guy, which is this one. There should be a negative sign. And then I take the, yeah, so then I keep this one. And then I take the derivative of these exponentials. And then this derivative of the exponentials give me that. Right, okay. So, sorry, it should be just this one. So everything should be, there should be no 1 here. Okay. Okay, so right now, let's see. So, okay, so after we factor out this guy, so then what we get is that, okay, so multiply by, okay, so maybe I add this one here. So times, okay, so first, the first one is left with just minus 1 over omega 1, right? And then plus, okay, so for the second one, I get 1 minus z over omega 1 times 1 over omega 1 plus z over omega 1 squared. Okay. Okay, I'm just copying this one here and then this one here. Okay, so okay, then close bracket. Okay, so let's see the second one. Okay, so for the second one, the first product is kept, right? And then the second product is being taken the derivative of. And then the third product and until the end is also being kept. So therefore, when we divide the whole thing, right? So what's left is just the z times the second one, right? Okay, so 1 minus z over omega 2 exponentials to the z over omega 2 plus 1 half z over omega 2 squared. And then same thing, right? So yeah, so maybe I just cancel out with the exponentials, and then what's left is just the multiply by that z times, okay, so negative 1 over omega 2 plus this guy. Okay, so maybe I'll just cancel out with this one also. Okay, so plus 1 minus z over omega 1 times 1 over omega 1 plus should be omega 2, right? z over omega 2 squared. Okay, so and then I think the rest is like the same until the end, right? So for the end part, so here, so there is a z left, right? And everything else is cancelled. And then up to there is a L and now prime z, right? Okay. So okay, so this is equal to what? Okay, so let's see what does this one expand as. So if we expand this guy on the numerator, so we get negative 1 over omega 1 plus we do the expansion 1 over omega 1 plus z over omega 1 squared, and then minus z over omega 1 squared, and then minus z squared over omega 1 cubed. Okay, so okay, and then yeah, so maybe I write it here. So minus z squared over omega 1 cubed, and then whole thing over z times 1 minus z over omega 1. Okay, so okay, so here is minus omega 1 plus omega 1 being cancelled out, and then this z, okay, so this z is being cancelled out with z here and z here, so left with just 1 here, and then z squared being cancelled out with 1 copy. Oh, okay, so this is also cancelled out. Okay. Okay, so okay, so let's see what we can do with this one. So let's multiply by omega 1 on both sides. So here we get negative z over, because I want it to appear as something like that. Okay, so let's see. So z over omega 1 squared over omega 1 minus z, right? But okay, so let's just leave it like okay, so let's leave it like that. So which is equal to negative z over omega 1 squared times omega 1 minus z, right? Okay, so can we do a partial fraction decomposition of this one? Okay, I think we can do that, right? Because I think this one is very familiar to me. So let's see. So Yeah, I don't think I need this one. Okay, so let's check this one. So let's first compute this one. So let's see. So 1 over z minus omega. Okay, so let's substitute omega 1 for this omega. So plus 1 over omega 1 plus z over omega 1 squared. Okay. So so here I find a common denominator, which is something like this guy first, right? Yeah, so maybe I change it to, because there's a negative sign here, right? So omega 1 minus z, I change it to z minus omega 1 in order to match with this notation here. So and then times omega 1 cubed. Shoot, omega 1 squared, okay. So here, this one I need to multiply by omega 1 squared, right? And here, this one I need to multiply by omega 1 times z minus omega 1, right? And then this guy I just multiply by z times z minus omega 1, right? Okay. Did I make a mistake somewhere? Okay. I think there's a mismatch because there is a z square, but there's no z square here. So this makes me thinking whether I made a mistake here. But I do make a mistake, because here when I multiply this negative z omega negative z over omega 1 and this z over omega 1 squared, right? So I just write z over omega 1 cubed. Sorry, negative z over omega 1 cubed, but it should be z squared over omega 1 cubed. Okay. So therefore this one should all be squared here. Okay. Okay, so here so this is equal to z over, so z minus omega 1, right, times omega 1 squared, and then I have omega 1 squared plus omega 1 times z minus omega 1 squared plus z squared minus z times omega 1. Okay, so this cancels out, these cancel out. Oh, sure, these two cancel out, and these two cancel out. Okay. Okay, so this is exactly the same as the sum of this zeta function here. Okay. So let's see. So okay. So okay. So Okay, so I think I made another mistake here because if so this kind of match this term, right? But where does this term come from? So I think when I try to take the derivative of this one, right? Oh yeah, actually I didn't make a mistake. Okay, so because there is this term, right? So the first term corresponds to a term where I take the derivative of just the single z itself and then keeping the rest the same. Okay. So when I take the quotient, this term should correspond to the part where this 1 over z comes from, right? Okay. So so there is still so there is still a question about this one, right? So what is this the limit function? Okay, so what is the derivative of this limit function over z? Okay, so the question is that what is this limit function ln naught prime z over z? Okay. Do I have time? Okay, so maybe I just illustrate what I'm thinking right now. So because I think there's a theorem about okay, so since we know that so this is a limit function, right? So I think I use the other way notation. So ln naught n converges to ln naught uniformly on any compact subset of d0 0 to r, right? Yeah, so we showed that before. So this implies that the derivative of yeah, so this means that the derivative of this function converges to the derivative of this one. Also uniformly on any compact subset of this disk. Okay. So like uniformly. Okay. So and I remember that this term is like the sum of log, right? From n now to this capital N. Oh yeah, from capital N now plus 1 to capital N of the log of the log of the log plus of the log plus 1 over some like plus 2 terms. Okay, so I think so then this derivative can be derived by taking the limit of this derivative, right? So basically we take the derivative of this term of these partial sums for each partial sums and then takes its limit. Okay, so then we shall get the derivative of this function. Okay, so we'll continue next time about the derivative part.